Not all substances are able to easily cross cell membranes. For example, oxygen and carbon dioxide can pass directly through the lipid bilayer of a cell membrane, whereas ions such as sodium and potassium cannot. These rely on protein channels to transport across the membrane. Whether or not a substance can pass through a membrane is determined by the characteristics of the membrane itself and the physical and chemical properties of the substance trying to pass through the membrane. So, for example, a physical property of a substance would be its size and shape, whereas the chemical properties would include whether it's a charged particle or whether it's a polar or non-polar. Small uncharged polar molecules like ethanol and benzene can permeate directly through the phospholipid bilayer. They cross the membrane easily and quickly, diffusing passively from high concentration to low concentration. Ethanol is an alcohol found in drinks, such as beer and wine, and the ease in which ethanol can diffuse into your cells is why people feel the effects of alcohol so quickly when drinking. Benzene is an organic compound that can be found in things like petrol and cigarettes. It is associated with a range of health effects and diseases, including cancer. Urea, a waste product formed by the breakdown of proteins, and water are also uncharged polar molecules that passively diffuse directly through the phospholipid bilayer. However, the phospholipid bilayer is only slightly permeable to these molecules, so that they do not diffuse across the membrane as easily as ethanol and benzene. Some hydrophobic molecules, such as oxygen, carbon dioxide, and nitrogen, are able to easily and quickly diffuse through the phospholipid bilayer. This is fortunate as it enables cells to obtain oxygen in order to undertake aerobic respiration and to get rid of carbon dioxide, which is the waste product of this process. Large polar molecules, like glucose, are not able to directly diffuse through the phospholipid bilayer. Instead, it relies on facilitated diffusion, where the glucose has to move through protein channels. Similarly, charged polar molecules such as amino acids, nucleotides, and nucleic acids cannot directly diffuse through the phospholipid bilayer. These molecules also rely on facilitated diffusion through protein channels. Charged ions like sodium, potassium, and calcium cannot cross the hydrophobic interior of the membrane. This is because uncharged molecules, in other words the phospholipid bilayer, repel the charged ions. This is the same reason that oil and water do not mix. Instead, charged ions rely on active transport, which occurs through transport membranes, and this is the basis of the sodium-potassium